Hello, good afternoon, ladies and gentlemen, and welcome back in our Paris Space Hub for our Rising Stars pitch session. 4 startups, we're going to pitch, 8-minute pitch each one of them, and we are talking eyes on earth, observing, understanding, and act. First pitcher is Romain Legros, CEO of Geoflex. Thank you for welcoming him. Come and join me on stage, Romain. Woohoo! The floor is yours.
Hello, so my name is Romain Legros. I am the CEO and founder of Geoflex. And in Geoflex, we are committed to enhance GNSS, Global Navigation Satellite Systems. So we are speaking about GPS, the American constellation, Galileo, the European one, GLONASS, Russian one, and Beidou, the Chinese one. And in Geoflex, we produce a correction data stream that enhance all those GNSS in 3 main topics. The first one is the accuracy of positioning. We pass the accuracy from few meters down to few centimeters everywhere in the world, both on land, at sea, and in the air, and even in space, up to 25,000 kilometers of altitude. We produce confidence level, so we augment the safety of GNSS positioning to be able to provide confidence levels surrounding the point to take into account a level of risk. And we augment the third component, the capability to resist to jamming and spoofing, to mitigate, to detect, to qualify, and to mitigate jamming and spoofing. The technology was developed initially by CNES, Centre National d'Études Spatiales. And in Geoflex, we are the operator of this technology. So we enhance the technology, we co-develop the technology, we operate it, and we commercialize it. So how does it work? We have a global infrastructure of about 140 GNSS permanent stations on ground. Each satellite is seen by at least 6 ground stations. And so dealing with those information on data center, we have a first software able to model in real time all the satellite-dependent error. In instance, orbit, clocks, and electronic biases. All those quantities are the same for all the users, and so we can broadcast those quantities to the user segment. And in the user segment, we have a second part of software able to synchronize this correction data stream with the observation of any GNSS receiver, whatever its brand is, to produce a precise, robust, and resilient positioning. So you can see in this picture what we obtain with a classical GNSS receiver with its antenna installed on a car on downtown. This is a red trajectory. If we apply our correction data stream and our technology to the same measurement, we obtain the green trajectory. And so, for example, for autonomous car, I assume that you will prefer to be in the green car instead of the red one. So we have a capability to perform tight hybridization with other sensors, to be able to pass under bridge, under tunnels, etc., doing tight hybridization. And we won, for example, the World Dubai Championship of Autonomous Vehicles with this bus equipped by our technology. This is the kind of bubble of confidence that we can compute to border a level of risk to be safe using GNSS measurement. And the third thing that we augment, as initially described, is the capability to resist to jamming and spoofing. And so to do this, after applying the concept, is to tell that after applying all the GNSS errors on the measurement are free of error. And so if it remains error, there is a jamming or a spoofing, and so we can detect it, and we can eliminate the measurement that are jammed or spoofed. And so this protection arrived in level 3, in the positioning engine. Previously to the positioning engine, we used GNSS receiver able to deal with radio frequency abnormality to be able to detect suspicious GNSS signal. And we used a dedicated antenna able to reject the signal coming from the side of the antenna that are abnormal due to the fact that the satellites are on the sky. So we have multiple realization in civilian markets. We won 2 CES awards. The first one for the accuracy, the second one for the safety for autonomous car. We work with Stellantis, Mercedes, Group Renault. We were awarded in the Software Republic. We are working with Thales Alenia Space, Safran, on LeoSat for PNT. In instance, the European constellation named FutureNav, to be able to locate very accurately the satellite, the LEO satellite by GNSS. We are working with Total Energy to be able to obtain the better GNSS positioning for Rigoi platform. And we are working with Group Bouygues for auto steering of dozer and other equipment. We are also working in defense for the capability to be resilient for jamming and spoofing. We start to work with the French Special Forces in 2018. And from them, we are working to equip conventional army through a program led by DGA, the French procurement agency. So if you have any question regarding what we do, we are all four on the booth A140, and so it will be my pleasure to explain you with all the required details what we do. Thanks a lot.
Thank you, Romain. Thank you very much for this nice presentation. Thank you. Next, I'm calling on stage now Philippe Latte, CEO of Leo Blue. Philippe, come and join me on stage. Where are you? Here he is. Sous les applaudissements de la foule en délire.
C'est bien. Merci Romain. Qu'est-ce que je fais avec ça?
Tu peux passer les diapos?
J'en ai. Hello everyone. So I'm Philippe Latte. I'm a founder of Leo Blue company. So the recent disaster in Valencia and in Majorque have shown that even in developed countries, we are no longer safe. Indeed, in Valencia, people will not be warned in time about the flood. In Mayotte, 95% of the terrestrial network have been destroyed, and the French government had to buy urgently Starlink antenna to be able to send basic information to population. And these cases are not isolated cases. The number of disasters is increasing each year about 17%, and the number of people affected by disaster, it's about 170 million of people, and the damage are around $300 billion each year. So we know that when you inform people before and after a disaster, you can reduce drastically the losses. But alert systems are not very common at worldwide level for two reasons. One, it's because the terrestrial network that are generally used for alerting people are covering only 10% of the planet. And these networks are very fragile. On the other hand, there are some promises from constellation, mainly American constellation, to be able to send alert system. But these mega constellations, they have some problem, and the non-sovereignty is one of the main issues of this constellation. And in any case, this system will remain very expensive because the infrastructure needed in orbit are very, very expensive. And in addition, all these solutions require modern smartphones to be able to receive information. So, what if the solution was in your pocket? In fact, all the 8 billion of the smartphones that are on the planet are using something in common, which is the Bluetooth chip. Oh, sorry. Okay, the Bluetooth chip, sorry. So if we are able to send information to smartphone from satellites using this Bluetooth chip, this could be really revolutionary because we will be able to send message to everyone on the world. It's exactly what we are doing in LeoBlue. We are developing a direct-to-device communication using Bluetooth. Till now, no one had used Bluetooth for massive messaging, mainly because everyone is thinking that Bluetooth is a short range. In fact, it's false. We have developed a patented technology to transmit information through Bluetooth over hundreds of kilometers. So last week we did some tests within a stratospheric balloon from the CNES to show our technology at 16 kilometers, which is a first record for the LeoBlue transmission. So we are a very solid team. I have 35 years of experience in space, in Airbus, Aerospace Valley, and other companies. My co-founder, Guillaume Ferré, is a qualified researcher in telecommunication. And we have as well, a board. And in particular, we have the inventor of the Bluetooth, Sven Mattinson, who is member of our board and who is supporting our technology. So now we are raising 1.5 million euros to develop a standard module to be hosted in one satellite and to be launched next year to demonstrate in real condition that we are able to send this information everywhere in the world. And after that, we will develop a network, in-orbit network of this payload to be able to develop within 3 years the first sovereign, universal, and affordable network for crisis management. So thank you for your attention.
Thank you very much, Philippe. All right, our next pitcher now is Pierre Pommiès from Prométhée. Thank you for welcoming Pierre. Thank you.
Hello everyone, thank you to be here. So I am Pierre Pommiès, I work for Prométhée. So Prométhée is a French company, but just before starting my speech, I want to talk about something. Philippe just explained to us that the number of crises just explodes in the world, even war or natural disasters. To observe these new disasters we face, we need capability to observe, to act and to decide. So we have a lack today of sovereign capability in Europe, in France, to observe. We need also tools to have a global coverage and also air revisit and air reactivity. In Prométhée, we are the French operator of new space. We operate a system from satellites to services. Our goal is to offer to France and to Europe and all our partners the capability to have means for near real-time information. To achieve our goal, we have designed a system. Divided in 4 different blocks. All these blocks are interconnected in order to provide near real-time information. Our first block of the system is what we call EOP, for the Earth Observation Platform. It's a digital platform used by all end users, very simple of utilization, that will give information and services for decision makers. This platform is designed to be very simple as possible for the utilization and is really focused on user need. But one of our big problems we have today is the massive quantity of data available, and we need tools, we need artificial intelligence in order to collect the data, but also to analyze the data. So our platform is directly linked with an AI-powered GeoInt engine. This engine is connected to the platform in order to index and categorize the data. Because we see today that during a lot of years, we do that. When we search for satellite data, we used two parameters, the location and the time. We want to change that because we see that we need information. For example, using this powered artificial intelligence system, now you can search from data, not from the time and not from the localization, but you can search from object. For example, if you are looking for a boat making illegal fisheries, you directly search from this boat and you will have all the data collected to this boat. But for that, we need our constellation. So it will be a constellation of 20 satellites, next generation satellite. This satellite is named Japetus. So we are supported by the CNES and the French ministry to develop this satellite. It's a microsatellite by 50 to 60 kilos, multispectral submetric resolution, sorry. It will allow us, thanks to our 20 satellites, to have intraday revisit and hyperactivity. The hyperactivity is our last block, but maybe the most important, because it's a technical part that is not able currently in the market. So we use onboard intelligence and inter-satellite links. We mix these two technologies to reduce the latency between the time where a user will ask for an information and you will receive it. Thanks to this technology, we'll be able to give an information in less than 15 minutes. So all this system is connected. It's what we want we develop it currently. We didn't it in ourselves. We used a lot of partners to do that. We are well connected in the French ecosystem, and we want to catalyze the new space ecosystem with our system. So we work with a lot of companies. For example, for the inter-satellite links, we work with Kinei, so the French IoT constellation, to make interconnection between our satellite and their satellite. We have recently made an interconnection also with the ground segment network of Skynopy, in order to achieve this important achievement to produce sovereign data. So our solution for a better, safer world, we have two different business models with always the same goal: produce near real-time sovereign information for our customer. The first one is what we call Earth Intelligence as a Service. It will be all the services and all the products we could propose thanks to our system. But we go also further, because we see today that many countries want to have their own Earth observation system. We have made this system, we have developed it, and it's a very, I would say, simple system. It's a new space system, so it's very simple to use. And we propose for a country who wants to have the sovereign capabilities to benefit from our experience, to lead them in the construction of the new space ecosystem, thanks to an Earth observation program, scalable and affordable. Thank you for your time, and if you have more questions, if you want any information, we are on the booth of the GIFAS, but also on the Ministry of Defense. Thank you.
Thank you, Peter. Thank you very much. Our last speaker, as you can see here, is Théophile Lagrolet. He's a CEO of Space Locker. Thank you for welcoming him. Thank you.
Un, deux, un, deux. OK. All right. Good afternoon, everyone. So I'm Theo. I'm the co-founder and CEO of Space Locker. And Space Locker, we specialized on shared space mission. And our objective is to democratize the use of space missions because we're convinced that this is the future of space and of the space industry because it's a way to send sensors in orbit in a much faster, simpler, and more sustainable way. So we're going to talk about Earth observation today. And I'm going to start with this picture with four cases that have one point in common. The first one is a fire in the southwest of France. The second one is a ship in the port of Amsterdam. The third one is agriculture in Canada, actually. And the last one is a battlefield in Ukraine. So all those four cases, they have one point in common, although they are at the four very different points in the world and for very different situations. They use Earth observation at some point. And it's our topic today. And actually, in France, we're very good at Earth observation. We've done many satellites for Earth observation, and in Europe, actually, too, very large satellites that are very good for very precise observation. And we're actually one of the real leaders in this sector for years, and France has been among the top players about Earth observation. Problem is, when you want to see things moving, you cannot afford yourself to have a very precise observation, but that will be every 3 days or every 7 days or even 15 days, because you actually don't see things moving. So if you take this picture and you ask yourself, well, is this ship arriving at the port or is it leaving the port? And it's actually a very important question when you want to use Earth observation. And that's where high revisit rates are very important. And you have a lot of companies that has been working on that. And Prométhée, before that, was a very good example of that. But to do so, you need a very high number of satellites in orbit, because you need to have a very high number of sensors in orbit. All right? The problem is, currently deploying a very high number of sensors in orbit is something that is extremely costly, extremely long, and extremely complex. So how do you solve this problem? Well, at Space Locker, we propose to share sats to have much more capabilities to send sensors in orbit. So what we do is that most of the time, you have a bit of margins on board every satellite that is currently lifting off. We can talk about constellation of mega constellation of telecoms, sorry. You can talk about large satellites for Earth observation, for instance, etc. And at Space Locker, our core expertise is to leverage those margins to host sensors on board those existing satellites. It's actually a way to send sensors in orbit in a more cheaper way, in a faster way, and in a more sustainable way. In the middle, you have our second mission. It's a sensor that has been integrated in 30-second watch in hand, okay? And it's not just for the show. A payload that size would have taken 3 to 6 months to be integrated on an existing and dedicated satellite. So we are critically taking this time of integration down to make space more accessible and faster. And the last point is actually not neglectable too. We're talking about Earth observation. We're talking about understanding our Earth. But if you want also to preserve our Earth, we need to take care of the impact that the space industry has. If we're sending thousands of satellites and polluting the Earth to try to observe it, it makes no sense. So by sharing satellites, you reduce the footprint of every satellite that you send by approximately 30%. And you create much less debris in orbit because you actually aggregate those sensors on board much more reliable and much more controllable spacecraft. That being said, we're not just a PowerPoint company. We already have stuff in orbit. You see here, and it's actually one of the first time that we show all those stuff publicly. You have our first mission that is already in orbit, in LEO orbit at 500 kilometers with on board 3 customers. Then on the second picture in the middle, you have actually 2 customers that will be lifting off on our second mission. And you have the development kits of our third mission that are already being sent to our customers for our third mission. We're working with a lot of partners because, as you might have understood, our role in the ecosystem is to connect people that want to send sensors with people that have vehicles. So you have very good examples of large players such as the Kines and ESA on that side. We're working with Thales Alenia Space, which is one of our long-time partners on the industrial side, and we're very proud of that. So the next step is what? The next step is that for now, we're hosting those sensors on board single missions, single sat missions. It's very good. It's a very nice way to send quickly sensors in orbit. And we're actually hosting most of the startups that you will see here in the Paris Space Hub because we are a way to demonstrate things super quickly in orbit. But we're not stopping here. And we are actually working currently with a lot of constellations to host sensors at scale and to be able to host Earth observation sensors, telecom sensors, or a very wide type of sensors on board large constellation. And so we're not talking about single missions anymore. We're talking about hundreds, thousands of sensors that we're able to send each year in a very fast, cheap, and sustainable way. So we are Space Locker. We believe that the future of space will be shared. And I was glad to pitch you Space Locker today. Thank you for your time.
And thank you very much, Theo. Thank you so much for your presentation. And of course, all these startups are available on this Paris Space Hub. So go ahead and go interact, meet them, ask them questions and everything. They'll be here all week. All right, coming up at 4:30 then, the presentation of the Aile de France Foundation 2025 scholarships. So stay tuned. We'll see you back here at 4:30. Thank you so much.